Hello everyone, my name is Vanilla. I am here with you to discuss about deep learning in computer vision. So let's go into the deep learning and then what are the importance of the deep learning in computer vision and the applications of the deep learning in computer vision. So first of all, let's see what is deep learning. Deep learning is a subfield of machine learning concentrated with algorithms inspired by the structure and function of the brain called neural networks. Deep learning is also known as deep structure learning. It is the part of a broader family of machine learning methods. It is based on the artificial neural networks with representation learning. Deep learning allows computational methods of multiple processing layers to learn and represent data with multiple levels of abstraction, mimicking how the brain perceives and understands multimodal information, thus implicitly capturing structures of large-scale data. Deep learning is a rich family of methods with neural networks and probabilistic models and a variety of unsupervised and super machine learning algorithms. The recent surge of interest in deep learning methods is due to the fact that they have been showing a outperform previous state-of-the-art techniques in several tasks, as well as abundance of complex data from different sources like visual, audio, medical records, social and sensor records, etc. So we can see that among the most prominent features that contributed the huge boost of deep learning are the appearance of large, high quality, publicly available labeled data sets along with the empowerment of parallel GPU computing. So we can say that there are many good methods that are present in deep learning, which will help us to have great applications in the future. So let's now what is meant by the artificial intelligence. It is mimicking intelligence of behavior pattern of humans or any other living entity. Machine learning is the technique which a computer can learn from data without using complex set of different rules. This approach is mainly based on training a model and dataset. So from this layer, deep learning presents. It is the technique to perform a machine learning inspired by our brain's own network. So what is the computer in vision? Whenever we get a data and a picture, the computer stores in the form of this image that is shown in the screen. It will have just a matrix numbers of size 1080, 1080 and 3 for an RGB. This is how the computer can store it. So by using the deep learning techniques, we'll be giving a knowledge of him to take the data how it will. Now deep learning methods. There are many deep learning methods. There are convolutional neural networks, deep belief networks, and deep Boltzmann networks. Stacked diionized autoencoders. These are the three available methods. So now let's see about convolutional neural networks. A convolutional neural network is a neural network that has one or more convolution layers and are used mainly for image processing and classification, segmentation, and also for the autocorrelation data. It is mainly inspired by the usual system structure. The most common use of CIN in recent times is image classification. So it has a very abundant uh, uses in image classification. Like most of now Facebook and etc. are using the CNN methods for the image classification. Like Google Photos all are using the CNN networks photo recognition. So basically, a CNN is compromises three types of neural layers. Those are convolutional neural layers, string layers, fully connected layers. So CNN are basically layers of convolution followed by subsampling and fully connected layers. If you speak correctly, convolutions and subsampling layers work as future abstraction layers, while a fully connected layer classifies which category current input belongs to using extended. So convolution layer is the core building block of the CNN. It carries the main portion of the network's computational load. This layer performs a dot product between two matrices where one matrix is the set of learnable parameters, such as otherwise known as kernel, and the other matrix is the restricted portion of the receptive field. The kernel is spatially smaller than an image, but is more in depth. It means that if the image is composed of 3 channels, the kernel height width will be spatially small, but depth extends up to all 3 channels. In the convolutional layers, a CNN utilizes various kernels to convolve the whole image as an intermediate future maps, generating various future maps. So next comes the pooling layers. Pooling layers are in charge of reducing the spatial dimensions with height of the input volume for the next convolutional layer. The pooling layer does not affect the depth dimension of the volume. The operation performed by this layer is also called as subsampling or downsampling, as the reduction of the size leads to a stimulation loss of information. However, such a loss is beneficial of the network because the decrease in size leads to the computational overhead of the upcoming layers of the network, and also it works against overfitting. Average pooling and max pooling are the most commonly used fully connected layers. Following several convolution and pooling layers, the high-level reasoning in the neural is performed via fully connected layers. Neurons in a fully connected layer have full connections to all activities in the previous layer, as the name implies. Their activation can hence be computed with a matrix multiplication followed by a bias offset. Fully connected layers eventually convert the 2D futures into a 1D future. Deep belief networks and deep Boltzmann machines. So these networks are the deep learning methods that belongs to Boltzmann family, in the sense that utilize the RPM as a learning module. See, the RPM is a generative neural network. It has an unidirected connections at the top of the two layers, which form a RPM, and directed connections to the lower layers. Deep of undirected connections between and all layers of the network. So deep belief network and deep Boltzmann machine, the top two layers of DBM from an undirected graph, and the remaining layers form a network with directed top-down connection with all connections undirected, as we can see in the image. Stacked Dionis autoencoder. An autoencoder is a neural network used for dimensional reduction, that is for the future selection and attraction. Dionized autoencoders are an extension of the basic autoencoders and represent a version of it. So the deionized autoencoders attempt to address identity function risk by randomly corrupting input. The autoencoder must then reconstruct or so let's see with the applications in the computer vision of the deep learning. So number first one application is object detection. Object detection is the process of detecting objects of segments of a certain class, such as humans or airplanes or boats, in digital boards and the video. A common approach for object detection frameworks includes the creation of large set of candidate windows that are in SQL classified using structure. And the next comes is here is the example. See, if you can see here, it is a picture where there is a person present. We can from the picture we can select the person, and it is a motorbike, and it is a car present in it, and this is a ladle. And here we can see a horse and the man. We can from different motions we can find out there is a picture or else board in the picture. So next comes is a face recognition. Face recognition is one of the hottest computer applications, computer vision applications that is going on. CNN has brought a great change in using these words. Now, nowadays, Google's FaceNet and uh, Facebook are using deep learning tactics of CNN to find the models. First, they create a 3D model, and then to fully connect later, it will connect it into a minutes. And the next important one is action and activity recognition. Like deep learning is now widely used to find the motions of the people, like in the find a football match or any kinds of volleyball matches. They are able to find the motion activity of the person that is. And the next is human pose estimation. So is to determine the position of joints from the images and sequences. So before it was very difficult to find this human pose. It was mainly used with the background pattern, but with the improvements of this one, human pose is easily example like pictorial structures and everything. We can find this human pose easily in deep learning. Next comes is the data sets. The data sets with due to the various kinds of data sets that are available in social media, so they have a very high range uses for in deep learning, like grayscale images or RGB natural images, hyperspectral images, facial characteristic images, medical images, video streams, and all these has a very good advantage applications of the deep learning. And CNN proves to be one of the majorly used technique for all these applications. So this is a brief introduction of deep learning in computer vision with these methods and some of the examples explained. Thank you, and these are answers. Thank you.